Let's start taking a look at the problems in Chapter 6, Section 3. The first problem is to show that y equals sine of 4t for t between 0 and pi over 8 is a solution to the initial value problem dy dt equals 4 square roots of 1 minus y squared and y of 0 is equal to 0. An initial value problem is just a differential equation plus an initial condition. So a differential equation plus an initial condition. So here we have a differential equation. The differential equation always defines a family of solutions. In this case, they're all going to be antiderivatives because that's the level we're at with our differential equations. So the differential equation defines a family of solutions. And that means they have the plus c. The initial condition allows us to find plus c. So in this particular problem, we have a proposed solution to the initial value problem. So when we're asked to show that y equals sine of 4t satisfies is a solution to the initial value problem, that means it has to satisfy the initial condition and the differential equation. That's what an initial value problem is. It's just a differential equation plus an initial condition. So we want to show that y equals sine of 4t satisfies the differential equation the diff EQ if we want to be cool when we talk about it, and the initial condition. So to show that that y equals sine of 4t is a solution to the initial value problem, we need to show that it satisfies the differential equation and the initial condition. So first off, that initial condition is really easy to demonstrate. So let's do that first. To show that, so if we just do y of 0, that means sine of 4 times 0 is equal to sine of 0, which is 0. So job done. It satisfies the initial condition. Now we also need to show that this function satisfies the differential equation. So the differential equation says dy dt is 4 times the square root of 1 minus y squared. Because that's what a differential equation is. It's an equation involving a function and its derivatives, in which the unknown is the function. So we're proposing that sine of 4t satisfies this. So let's figure out what dy dt is. So if y equals sine of 4t, then dy dt is, if the derivative of sine of something is cosine of that thing, times the derivative of the inside, so 4 cosine of 4t. So if we look at what we have 4 square roots of 1 minus y squared. We can see how this is, we're going to use trig identities to make cosine of 4t look like 4 times the square root of 1 minus y squared? So now we're just going to manipulate 4 cosine of 4t to make it look like 1 minus y squared. Oops, 4 times 1 minus y squared. That's going to be our plan. We're going to take the 4 cosine of 4t, and we're going to make it look like square root of 1 minus y squared. So cosine of 4t. So cosine of 4t, I'm going to use the identity where sine squared theta plus cosine squared theta is equal to 1. So what that means is that cosine of theta is the square root of 1 minus sine squared theta. So I'm going to write this as 4 square roots of 1 minus sine squared of 4t. And sine squared is equal to, sine of 4t is equal to y. So this is equal to 4 square roots of 1 minus y squared. We can also approach this from the other side by looking at the expression 4 times the square root of 1 minus y squared and showing that that's equal to 4 cosine of 4t, which is equal to dy dt. So if we come at this from the other direction, if we just write 4 times the square root of 1 minus y squared and replace y with our proposed solution, sine of 4t, this becomes 4 times the square root of 1 minus sine squared sine squared of 4t. And so now we're using the same trig identity. 1 minus sine squared is cosine squared. And the square root of cosine squared is cosine. There is a small concern here. The square root of something squared is not actually always the thing because cosine is sometimes negative. But for t between 0 and pi over 8, that means 4t goes between 0 and pi over 2, and sine and cosine are both positive in the first quadrant. So we're okay. So we should also note so 0 less than or equal to t less than or equal to pi over 8 means 0 is less than or equal to 4t, which is less than or equal to pi over 2. And sine and cosine are positive in the first quadrant. So when we take the square root of cosine squared, that should be the absolute value of cosine of 4t. But since we're in the first quadrant, we can just keep it that way. Any questions?
Yeah, why does the cosine squared disappear and becomes 4
Right
cosine 4t? Yeah.
Because it's the square root of cosine squared. So the square root of a square will just give you the base.
And it doesn't apply to the 4t?
No, because it's the cosine that's being squared. So it's x squared. It's the square root of x squared, and that's just x. In this case, the x is a cosine of 4t. We're not taking the square root of 4t. 4t, t gets multiplied by 4, then we take the cosine, then we square things. Because what this expression looks like is the square root of cosine of 4t squared. So cosine squared of 4t is notation for the square of the cosine of 4t. So we're not taking the square root of 4t. 4t is not a factor under the radical, because that would mean cosine is all by itself, but cosine by itself means nothing. Cosine of what? Any questions?
Professor, what does QI means?
QI is quadrant 1.
Okay. And then how do we reach from pi over 8 to 4t? Oh, pi 2.
Multiply by 4.
Got it.
Because the thing that we're plugging into the cosine and the sine is 4t. Since t is between 0 and pi over 8, 4t is going between 0 and pi over 2. So just multiply everything by 4. Pi over 8 times 4 is pi over 2. So that's why the pi over 8 part was there. Any other questions? All right. Let's pause video here and move on to more problems.